In this lesson, we're going to talk about how to use the order of operations agreement to solve different types of problems. And it's important for you to do lots of examples here. So I've got several examples included in this video for you. So this will be one of the longer lessons that we'll have. Let's take a look. Just like in traffic, we have to have a way for people to know what operations come first. You know, in traffic, you have to have rules that you follow, like who gets to go first at the stop sign. And when we have math expressions, it's important to know which operations take precedence over others so that everybody reads the same problem the same way. So, mathematicians have agreed this is how we're going to write math. It's going to follow the rule of PEMDAS, where each of these stands for an operation. P stands for parentheses, or any grouping symbols actually. So that's not so much an operation as it's just saying anything that's in parentheses gets to be done first. So parentheses first, then E for exponents, then M and D stand for multiply and divide. So these should be done in order from left to right. A lot of people look at PEMDAS and they think, okay, I'm going to do all the parentheses, then all the exponents, then all the multiplying, then all the dividing, and that's not true. Multiplying and dividing are equal in rank, and therefore they're kind of tied, and so you have to do them as you come to them as you're going left to right. Same thing with adding and subtracting. So A and S stand for adding and subtracting, and that should also be done in order from left to right. So remember when we talked about the commutative property, we said there's no commutative property of division and there's no commutative property of subtraction. So that's why going in order from left to right is important. Now if you want to convert your division into multiplication, the way we've learned how to do, or if you want to convert your subtraction into addition, the way we've talked about before, you can do that, and then you can go in any order. But as long as you have both M and D, you have to go left to right. As long as you have both A and S, you have to go left to right. So let's take a look at a few examples. So in order to keep up with your steps, I'm going to want you to underline the next operation that you're about to do, and then on the next line recopy everything except that one step that you've done. And you'll see me do it as we work through these problems, but even though this leads to a little extra copying, probably more than you want to do, it's really important to keep track of your work and to make it easy to follow. So I recommend doing this, otherwise you're going to get yourself all turned around. So here's one for us to do. Simplify 3 plus 24 divided by 6 times 2. So I'm going to look at this. I'm going to say, do I have any parentheses? No. Do I have any exponents? No. Do I have any multiplying and dividing? Yes. That has to be done in order from left to right. So here I go. Here's the first, multiply or divide. So I'm going to underline the division I'm about to do. And then on the next line, I'm going to recopy everything. So you see 3 plus, but I'm going to actually work the 24 divided by 6 and get 4 times 2. So see how I underlined what I was about to do, and then on the next line I did it, but that's all you do. Now your choices are add or multiply. So obviously multiplying comes before adding and subtracting. So let's underline the multiplication, and then 4 times 2 is 8, and then 3 plus 8 is 11. So I think, just make sure that you underline the step you're going to do, and then on the next line do it and underline the next step you're going to do. So here's a new example for us. 6 minus 4 times 3 plus 5. So I have subtraction, multiplication, and addition. And so multiplying comes before adding or subtracting. Let's underline the multiplying. 4 times 3 will be 12, so on the next line I will copy but I will change 4 times 3 into 12. So now I have subtraction and addition. Remember A and S in order from left to right, so I have to underline 6 minus 12 is negative 6, and then negative 6 plus 5 is negative 1. Okay. I mentioned on a previous slide about how to change division into multiplication and subtraction into addition. And this is a really good way to keep from doing things in the wrong order. It's not so much that I want to change division into multiplication. I want to go ahead and put it in fraction form. And I want to change subtraction to addition in case there's ever any doubt. You only need to do that if you're not sure. But I think it will help you avoid some mistakes until you get really practiced at doing it. So let's do a few problems where instead of worrying about the order of the division and the multiplication, we actually just change all of our division to fraction form and all of our subtraction to addition form. And that cuts down on the doing things in the wrong order problem. So we're going to take a look at one of the problems we've already worked on. So see this division here? I'm going to rewrite this in fraction form. Anytime you see divided by, it means what comes next goes to the bottom. So the only thing that goes to the bottom is the 6. And watch how this looks now. See, instead of 24 divided by 6 in this stretched out form, I get 24 divided by 6 in fraction form. Now, because the 6 is in the denominator, that kind of forces you to, it kind of keeps you from multiplying 6 times 2. Because see, the mistake everybody makes here is that everybody wants to underline the 6 and the 2 first and do the multiplication first. But I think if you look at it in fraction form, you will not be tempted to multiply 6 times 2 because the 6 is in the denominator. So now, simplify. 24 divided by 6 is 4. And that 4 times 2 is going to make 8. And see, 24 divided by 6 is 4. And that 4 times 2 comes next, and that makes 8. And 3 plus 8 is 11, which is what we got before. I'm partial to this way of writing it because once you get your divided by things in the denominator, you no longer are tempted to do the multiplication first. So I like that. But once you get that done, then you cannot go in the wrong order, so it's foolproof. Now watch this. 24 over 6 is 4, and 4 times 2 is 8, right? But also, look at this. 24 times 2 is 48, and 48 divided by 6 is also 8. You see what I mean? About you can't do it in the wrong order. It's going to force you to divide by 6 no matter what, because 6 is in the denominator. So I think this is a good thing. So I want to do a couple of examples with you where we do look especially at converting our division into fraction form. Let's simplify 10 divided by 8 times 4. Now see, here's another example where somebody might say, well, I don't know what 10 divided by 8 is, so I guess I'll do 8 times 4 first, but that would be wrong. So what you do to solve the problem is you say, okay, I'm going to write this in fraction form. That always makes everything easier, and I know you've spent your whole life hating fractions, but fraction form is easier than this stretched out form. So let's look at it where the 8 is in the denominator. So now instead of 10 divided by 8, I get 10 divided by 8 this way, and then times 4. See, the 4 is still in the top. Now, if this were a fraction, you would just reduce, or you might do 10 times 4 first. It really doesn't matter. So I went ahead and multiplied. 10 times 4 is 40 over 8. See? So 10 times 4 is 40, And in the denominator, 8 times 1, which is invisible, is still 8. And 40 divided by 8 is 5. So, you know, here, if you do 10 divided by 8, you get a fraction. And then that fraction times 4. It's just that this is a little easier to comprehend. So I like it better. Okay, let's look at this one. 3 plus 2 divided by 6 times 18 minus 5. Alright, so what to do first? Well, clearly all the multiplying and dividing has to be done first. So let's rearrange our dividing into fraction form. That means the 6 will go down to the denominator. So 2 over 6 times 18 minus 5. Now, this is 18 over 1, so you might reduce the 18 over 6, or you might do it a different way. It doesn't. See, now that we have it in fraction form, you can't do it in the wrong order. So I'm going to do the simplifying here first. 18 over 6 simplifies to 3. So I kept my 3 plus 2 times 3. See, my 18 over 6 has now simply become 3 minus 5. And now the next thing we have to do is the multiplication. So 2 times 3 is 6. And now we add and subtract in order from left to right. 3 plus 6 is 9. And 9 minus 5 is 4. And see, I just want to point out again that if you had done this the way you're supposed, the way the book tells you to, you would say 2 divided by 6 and you'd get a fraction. And I dare say a lot of us would say 2 divided by 6 and accidentally come up with 3 because we divide in the wrong order. Or you might do the multiplication here first and totally mess everything up. But if you look at it in fraction form, it can save you some headaches sometimes, makes your simplifying easier, makes it easier to see what you've really got going on. So I really can't encourage that enough. On this next example, we're going to get to see exponents for the first time. So remember in PEMDAS, parentheses come first, but we don't have any parentheses yet, then exponents. So I do have a couple of exponents here, and I need to take care of those first. So 6 squared is going to make 36. Keep everything else the same. And then 2 squared is going to make 4. So I've changed my 6 squared to 36, and 2 squared changes to 4. Now I see a division symbol here. Let's change our division into fraction form. So now it's up to you. Do you want to simplify 24 over 4? Or do you want to multiply 24 times 3 and then divide by 4? Totally doesn't matter. I think I would like to do the simplifying first because that keeps the numbers smaller. So 24 divided by 4 will make 6. Then 6 times 3 will make 18. And now we go left to right. 36 minus 18 is 18. And 18 minus 1 is 17. Okay, now remember, you need to go left to right. And I'm going to show you what happens with your subtraction if you don't go left to right. So here's 36 minus 18 minus 1. So occasionally somebody will look at this, and I guess because this one is easier, they'll go 18 minus 1 first, which makes them think they have 17 here. And then 36 minus 17 is 19, but that's not correct. So instead what they could do is change the minus to a plus and change the sign of the next number. So instead of minus 18, we get plus negative 18. And instead of minus 1, we get plus negative 1. Now we've talked about this before. And if you already can do the subtraction without doing this and not mess it up, then okay. But you need to remember that every time you see minus, you're really going to think plus negative. So here, if I could think negative 18 plus negative 1 and get negative 19, like I would here, then I can say 36 plus negative 19 gives me 17. So it's only when you treat these as addition that you can go in any order you want. If you're treating these like minus signs and you're going to say 18 minus 1, well, that's going to mess everything up. So just keep that in mind, that you're going to only change the order if you're treating these as negatives. So we got that one right. In these next few examples, for the first time, we get to see parentheses. So parentheses and other grouping symbols like brackets are going to take priority over all the operations. Parentheses are a way of saying, hey, I get to come first. It's a way of letting some operations cut line in front of others. So let's simplify. Parentheses 2 times 5 parentheses squared. Okay, well, the 2 times 5 gets to come first. Normally in PEMDAS, we would need to do the exponents first, but the parentheses say, hey, I get to go first. So 2 times 5 is 10, and then 10 squared would be 100. 10 times 10 is 100. Okay, let's look at the same problem without parentheses. This time, because there are no parentheses, the exponent takes precedence over the multiplication. So if we use the exponent first, 5 squared, 5 times 5 is 25, and 2 times 25 is 50. Now parentheses can also be used as multiplication symbols we have seen before, but when they say do the parentheses first, they mean do any operations that are inside the parentheses. Just one number inside a set of parentheses is really probably standing for multiplication. So parentheses first just means work the operations in the parentheses first. Only one number in the parentheses you treat as multiplication. And I'm sure we'll get to see that some more later on. Alright, let's try to simplify 2 bracket 5 times parentheses 4 minus 7, close the parentheses, plus 9, close the bracket. Okay, so clearly 2 times something, we need to find out what is in this bracket first before we can do the multiplication. And you can't even distribute that 2 right now because there's too much stuff in here. These parentheses are messing you up. So let's do what's inside the parentheses first. 4 minus 7 will be negative 3. So notice I underlined the 4 minus 7, and then on the next line I show the result of 4 minus 7. But I've still got parentheses because it's a negative number, so it didn't seem appropriate to use the dot. But now I need to work this multiplication because multiplication takes priority over addition. So now let's multiply 5 times negative 3, and we'll get negative 15. And so I've copied everything just the same except I worked out 5 times negative 3. Now you have a choice here. You may distribute the 2, or you can work what's inside here. It really doesn't matter. Same thing would have been true up here. You could have distributed the 5. It's really up to you. The distributive property does still work, but a lot of times it's easier to work this addition. So let's just do negative 15 plus 9 is going to be negative 6. And then 2 times negative 6 is going to be negative 12. So, after we did this 4 minus 7 and got negative 3, then there was nothing to do inside this parentheses. So the parentheses were finished, and all we had to do then was multiplication. I just want you to see how the P for parentheses does not mean that parentheses get to go first. If there's only one number in the parentheses are really acting like a multiplication. So it means do what's inside the parentheses first. All right, here's another one that involves both brackets and parentheses. And we've got a division here as well. So maybe we'll make a fraction out of that. We'll see. All right, so let's decide, we've got division and addition and brackets. So P for parentheses says the brackets have to come first. Now inside the bracket, I still have to follow PEMDAS. So I've got parentheses and exponents, and so let's see what we have to do. The parentheses first, right? Inside the brackets, 8 minus 10 will be -2. So I did go ahead and convert that to a fraction. There's no harm in that. But the only other thing I did was 8 minus 10 is -2. I've still got my exponent. Okay, now look at what you've got. Plus and times and exponent. What has to come first? Exponent comes before M or A. So let's figure out what is the exponent for? What is the base of our exponent? And the base is -2. So -2 times -2 times -2 is going to be -8. Alright, now I've got plus and I've got times. Which comes next? Well, times comes before addition. So 2 times -8 will be -16. And notice, I could have written 5 minus 16 here instead of plus negative. It's up to you, whichever you prefer. But we do need to finish working what's inside the parentheses, what's inside the brackets. So 5 minus 16 is going to be -11. Now, I have division here and multiplication here. If I do them in order from left to right, then I may as well do them in the same step because they're not going to affect each other. 18 divided by 6 is 3, and 4 times -11 is -44, and 3 plus -44 is -41. Now let's look at this big fraction bar. Some of these problems have a long fraction bar in the middle. And what this does, it acts like a big division symbol. And basically you can think of it like the top is in parentheses and the bottom is in parentheses. Although the parentheses are not written, the fraction bar kind of makes them understood. You can assume that they are there, but they're not really written. And all that we do is work the top and the bottom separately and then put them together at the end. These are some of the most difficult looking problems, but in reality they're actually some of the easiest problems that we'll have. So let's simplify 2 times parentheses 3 minus 12 plus 6 times 4 over 2 to the 4th plus 1. So we're going to take the top and the bottom separately. Here's just the top. So I've got parentheses. I need to do what's in parentheses first. So 3 minus 12 is -9. Now I have a multiplication here and another multiplication here. May as well do them both at the same time. 2 times -9 is -18, and 6 times 4 is 24. And then -18 plus 24 is 6. So this is going to become the top of our answer. And now we work on the bottom part. 2 to the 4th plus 1. Well, 2 to the 4th would be 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So I have 4 2's multiplied in there. That's going to make 16 plus 1. which is 17. So the top of my answer is 6 and the bottom of my answer is 17. 6/17. And if this could be reduced, we would do that, but it cannot, so this one's finished. Got a couple more fraction bar examples for you. Let's look at 6 squared minus 4 squared over 2 minus -8. Okay, so in the top, we have 6 squared minus 4 squared, and PEMDAS says that exponents have to come before subtraction. So 6 squared is 36, and 4 squared is 16. Now 36 minus 16 is 20. And let's look at the bottom. 2 minus -8. Well, we know minus negative becomes plus, and 2 plus 8 is 10. So I'm going to end up with 20 divided by 10, which is 2. So this one just simplifies down to 2. Here's another one. So I have this big complicated looking top, -11 times -4 plus 2 times -7. And on the bottom, 7 minus -3. So we take them one at a time. -11 times -4 makes +44. And 2 times -7 makes -14. Now 44 minus 14 is going to make 30. And 30 will be the top part of our answer. And now let's take the bottom. 7 minus -3. Minus negative becomes plus, and 7 plus 3 is 10. So now I have 30 divided by 10, which is 3. And so, again, just make sure you, after you put your top and bottom together, make sure you simplify if you can. Now let's look at evaluating. So evaluate means that we're going to start out with an expression that contains a variable, but they're going to give us a number to substitute in place of that variable. And usually it's best to put that substitution in parentheses so that you don't make any accidental sign errors. So here's our first example. Evaluate x squared minus 7x for x equals -2. So all I'm going to do is replace this x with a -2. See, everywhere I used to have x, I now have -2. And where I used to have x, I now have -2. Once you get the x replaced with the number, it's just a PEMDAS problem. So we have to go through parentheses, exponents, multiply and divide, add and subtract. So P for parentheses. I do see parentheses here and here. But does that mean I have to do this first? No. Actually, because there's only one number in this parentheses, so there's nothing to do in there, so I proceed to the next step. E for exponents. So this is the exponent and -2 is the base. -2 times -2 is +4. And I've gone ahead and done this multiplication because after your exponent step, the next step is multiplication, so I went ahead and did it here. So 4 plus 14 is 18. And we're going to try another one. And this is a fraction bar problem, but they tell us to substitute 5 for the y. So in the top, where I used to have y, I have now put in the 5. And in the bottom, where I used to have y, I have now put in the 5. And we'll work them separately. The top, okay, P for parentheses, but there's nothing to do in these parentheses, so go to the next step. E for exponents. I do have an exponent, so 5 squared is 25. Keep everything the same, but work out the exponent. Now M for multiplication. So I do have two multiplications here and here. And so let's just do them left to right. 3 times 5 is 15. And 2 times 25 is 50. And now the subtraction, 15 minus 50, is negative 35. That's the top part of our answer. And now let's do the bottom part. 5 times 5 minus 2. So 5 minus 2 is 3. And 5 times 3 is 15. So it looks like our answer is negative 35 over 15. But of course you notice that this can be simplified because both of these numbers can be divided by 5. So let's do that. And we'll end up with negative 7 over 3. Alright, if no value is given, we will not be able to get rid of the variable, so we'll still have a variable in the problem, in the answer rather, and that's okay. It really just comes down then to a combining like terms type of problem. So let's look at an example of that. Here I've got 18x squared plus 4 minus bracket 6 times parentheses x squared minus 2 plus 5 bracket. Okay, they're not going to tell us a value for x here, and all we can do is simplify, which means if there are x's in the expression, there will still be x's in our answer. So here I have plus and minus and bracket. So clearly I need to work what's in the bracket first. Inside the bracket I have multiplication, parentheses, and plus. So I need to do what's inside the parentheses first. But can you really do this? X squared minus 2, because these are not like terms, you're not going to be able to do anything to it. So if you can't do it, you can't do it. So go on to the next step. E for exponent, but the base is a variable itself, so you can't do that either. So that leaves us with M and D. We've got multiplication here. So we can distribute the 6. That's a multiplication step. So let's distribute the 6. Keep everything else the same, but 6 times x squared is 6x squared, and 6 times minus 2 is minus 12. Okay, now inside the bracket, do I have any terms that can be combined? The answer is yes. I have negative 12 and positive 5. So negative 12 and positive 5 are going to give us minus 7. Now, inside the brackets, can you do anything to simplify? The answer is no, because these are not like terms. So now we go outside the brackets. Can you distribute this minus? And the answer is yes. So we distribute the minus sign. Remember, that's like a multiplication step. And we're going to get negative 6x squared, and negative 7 makes plus 7. Now, let's combine like terms. I have a positive 18x and a positive 18x squared and a minus 6x squared, which gives us 12x squared, and a 4 plus 7, which gives us 11. And that one's done. So I know when you look at these, they look a little intimidating to you because, you know, you're still kind of new to algebra. But keep the rules of the road in mind. And, you know, one more time, if you're thinking about parentheses, well, you look inside the parentheses and see if you can do anything. But if the answer is no, go on to the next step and don't worry about it and don't feel stuck. Just go ahead and do what you can. That's all anybody can do. Alright, let's simplify. 6 minus 5 times 8 minus parentheses 2y minus 4. Okay, so I know I have to work inside the bracket first. What can I do inside the bracket? Well, I have 8 minus this parentheses. So I kind of think, okay, parentheses first. Is there anything I can do in the parentheses? There is not, because these are not like terms. So, is there anything I need to distribute? Yes, I need to distribute this minus sign. So, let's copy everything the same, but negative 2y is here, and negative 4 makes plus 4. Alright, now, inside the bracket, can you combine any like terms? Yes. 8 plus 4 is 12. So I get, inside the bracket, I get 12 minus 2y. Now, out here, everybody who works this problem tries to make the mistake of doing the subtraction first and then distributing after you subtract. But you got to remember, distributing is a multiplication step, and multiplying has to come before subtraction. So, let's distribute this negative 5. Negative 5 times 12 is minus 60, and negative 5 times negative 2y will be plus 10y. Okay, now combine your like terms. 6 minus 60 is going to be negative 54, and you've still got your plus 10y. So we end up with negative 54 plus 10y. One more example together. We've got 14x squared plus 5 minus bracket 7 times x squared minus 2 plus 4, close the bracket. Okay, so again, we know we have to work inside the bracket first. Inside the bracket I have parentheses, so I have to do that first. Is there anything I can do inside the parentheses? No, these are not like terms. Okay, exponents come next. Is there anything I can do with that exponent? X squared. No, x is a variable, so you can't write it any simpler way than x squared. Okay, after E comes M and D. So, is there any multiplying? Yes, I can distribute the 7. That's a multiplying step. So I'm going to keep everything the same, except I'm going to distribute the 7. 7 times x squared is 7x squared, and 7 times minus 2 is minus 14. Okay, inside the bracket, is there anything I can simplify? Any terms we can combine? Yes, negative 14 plus 4 is going to be negative 10. So I kept everything the same except for the minus 10. I worked out that addition part. Okay, now outside the bracket, I have plus and I have this minus in front of the bracket. Well, you know that means the minus must be distributed. So let's do that. So I'll still have 14x squared plus 5 minus 7x squared plus 10. Okay, now I'm down to no parentheses, and now it's just a matter of combining like terms. So 14x squared minus 7x squared gives us 7x squared, and 5 plus 10 gives us 15. And so we've done several examples together now, and I hope that you will work several on your own and refer back to this as needed. But the main thing is for you to get a lot of practice. How did you become a good driver? Because you drove on the roads a lot. Big roads, little roads, country roads, city roads, and driving in all different types of conditions makes you a good driver. Working all different types of order of operations problems makes you good at solving order of operations problems. So please do get lots of practice, and when you see one that looks hard, that's one you need to try. And you need to try all different kinds, and you just need to do them over and over. And I would suggest, go back through your notes and back through this video and copy down some of the problems we've worked together and see if you can work them by yourself. And if you get stuck, go to the video and get some help. But, these would be a good place to start because you can't get too lost because you have them worked out for you. And the more you work them and think about them, the better you will understand them and the better you will be able to work them when you see them on a test. So good luck.